Hello students, I am Professor Veena Joshi. I teach Geomorphology, Fundamentals of Geomorphology course GG 111, and we will be doing many more sessions with me today, and this is one of the most interesting part of our Geomorphology course. If you remember, in our last lecture we tried to learn about plate tectonics, how Earth is composed of big as well as small plates. Over the million and billion years, how they have been drifting apart from each other, colliding with each other. At the boundaries, what kind of tectonic activities and landforms are formed. Today, we will be coming out of the interior and tectonic, and will come up on the atmosphere. In this talk, in this lecture, we will be learning today weathering. When the earth or the rock is exposed to the atmosphere, how it starts softening and breaking so that the different agents of geomorphic agents can work over it. So, weathering precedes all the other atmospheric phenomenon. We will be now going to learn about weathering and their different types. Let us start with today's our lecture, that is weathering. Weathering, the picture that we see right now itself is part of weathering which we come across every day, on the everyday basis. When the rocks are fallen on the road, very frequently and very commonly we see the discoloration part which is surrounding the exposed part, like how, or if we go to a village or in a temple, many times we see the statue has got kind of eaten up. So, all that we see is nothing but the different images of weathering. Wherever we go, especially in Maharashtra, because it's a rocky country, we see rocks looking like a cabbage or onion which has been peeled off from outside. This is also another form of weathering. Or all over the Western Ghats, whether it is Lonavala or Mahabaleshwar or any part, we see the rock course, the rocks and the weather part. So, all that we see is nothing but they are weathering, or what we call it as lal mati, very, very common in mountainous area of all over India and especially Maharashtra. So, now let us define the term weathering. The term subaerial, so subaerial, aerial means wind, sub below, that means something which is on the surface of the earth. The term subaerial, that is literally under the air, is used to describe events or structures that are located at or near the surface. Weathering is the first step for a number of other geomorphic and biogeochemical processes. The product of weathering are a measured source of sediments for erosion and the deposition. So, let us define the in situ disintegration or breakdown and decomposition of rocks through the action of various elements of weather and the climate makes weathering. So, what is in situ? In situ in geomorphology or in geology stands for something which is standing at the same place. That means not moved anywhere. So, what this definition is trying to tell us is that a rock which is standing and sitting at the same position over the period of time has got decomposed or disintegrated. Strakov's 1967 diagram. This diagram shows from 0 degree to 90 degree. 0 degree stands for equator and 90 degree stands for pole on both the hemisphere. The rate and depth of weathering is maximum at the equator and it is very, very less at the middle part, or what we call it as the low latitude desert region, it becomes a little more in temperate regions. This fact or this diagram is indirectly going to suggest to us that for the weathering to proceed, the tropical conditions are very favorable. That means the combination of precipitation and the temperature, high temperature, which will give rise to high vegetation. So, I will be repeating it once again. Weathering. Weathering is softening and breaking of the rock standing in situ, have not moved from this place at all. There are two types of weathering. One is called as the physical weathering, the other called as chemical weathering. Physical weathering also is called as mechanical weathering. What it means? That it just disintegrates and breaks the rocks into smaller pieces. Let us take the example of a chalk. That I can take a chalk or I can take a piece of rock and I can just crush it. I can put it under a machine and crush it. The rock will become powder. So, it is disintegrated. But the composition, the mineral composition and all the property of that rock has remained as it is. So, mechanical weathering or physical weathering suggests no change in chemical composition, just disintegration into smaller pieces. And what the physical weathering does is, it breaks a rock into smaller pieces and it increases the surface area. Let us take the example of a block of 1 meter by 1 meter. I will break it into 8 equal parts. The area will become 6 into 1 upon 2 square into 8 into 12 m square. That means how the area is going to keep on increasing as the rock is becoming smaller and smaller, and the more is the superficial area, the more will be the rate of weathering. Whereas chemical weathering, when we say chemical weathering, we are actually talking about the chemical breakdown. That means internal change. Here I should need to bring it to your memory once again that rocks are composed of minerals, 2 and more minerals. So, when I say chemical weathering, the chemical composition of those rocks change from one to the other. Or in simple English or in simple word, we can take the example of milk turning sour. If we keep milk in the open for 1 day or 2 days, we know how it becomes. It turns sour. What is happening is it is decomposed, which in Marathi we call it as nasna, means it is decomposed. So, what is happening? It is the internal change. So, in case of physical weathering, there is no internal change. It is just a breakdown, becoming smaller and smaller. Whereas, in case of chemical weathering, the original composition of the rock, the mineral characteristics break down. So, now let us see, because by now we know there are two basic types of weathering. One is breaking down, one is decomposition or disintegration and decomposition. The first variety, which is called as physical weathering, let us discuss that now. There are 4 basic types of physical weathering. The first one is called unloading. The second one is called as frost wedging. The third one is called as salt weathering, and the fourth one is called as the insolation weathering. They, depending on what environment or climatic zone that we are dealing with, these different type of weathering will always be found when we are talking about physical weathering. So, mechanical weathering is the physical breakup which gives rise to physical pressure release, freeze and thaw water cycle, crystallization of salt in the cracks, and thermal expansion and the contraction. All these increases the total surface area exposed to the weathering process. Unloading. The diagram is telling by itself. Rocks are formed by cooling of lava, but there are some rocks which are intrusive. They are formed beneath the crust. So, when these rocks were formed, they were under tremendous pressure and the temperature. Erosion slowly exposes this, and once it comes on the surface, the pressure is released. So, it is from a very high pressure, it is being exposed to the, and the load is getting lifted up, which makes the rock starts expanding and breaking. This is called as unloading, and unloading gives rise to peeling off the top portion of the rock, like how onion is getting peeled. It gives rise to exfoliation. So, layer by layer the rock is going to be disintegrated and it is going to be broken in away from the system. So, exfoliation, rocks break apart in layers. A rock is uncovered, it expands due to the lower confining pressure, which results in exfoliation. The examples can be seen everywhere. They are mostly found in the granitic domes of Karnataka, Chennai, or such kind of unloading can be found even in basalt also as the core stones. The exfoliated domes, they are all the examples of such kind of breaking and sheeting, we call it as. So, that is one type, pressure release, and layer by layer the rocks are breaking and going away from the system. The second one is called as the frost wedging, frost, F-R-O-S-T. Frost stands for ice, and such kind of physical weathering is very common in areas where the temperature is very low and most of the time ice is there. So, in the cold areas or in the mountainous areas. In the cracks, water goes into the cracks and they freeze. Ice has got more volume than the water. So, ice is putting pressure in the rock. In due course of time, the pressure becomes so much that it breaks apart and it breaks the rock into pieces. So, frost wedging is the freezing and thawing of the water in the crack. So, then now the water will melt again ice will come. For the whole of winter it will stay, and when the summer comes again it will melt. So, this pressure and releasing gives rise to breaking by the ice, which we call it as the frost wedging. They are very common in all the areas where ice is there. You will find it on the top of the mountain, we will find in the higher latitude, in the polar areas, wherever the ice is there, it breaks the rock. We call it as frost wedging. So, it shatters the rock into pieces, making the rock very sharp. So, in the alpine and cold environment where freeze and thaw activity is there, they are very, very common, and there are several such examples. We can see the pictures on the internet as well. The next is salt weathering. They are mostly found in deserts where evaporation is very high. Salt accumulates in rock pores and cracks. Generally occurs by evaporation. The source include weathering product in water, precipitation especially near coast, and the aeolian dust. When the water evaporates, minerals are left behind to grow between the grains in the rock. Three minerals are mostly involved in the whole process, that is halite, that is a common salt, calcite and gypsum. Very interesting example. Salt is getting deposited after water is got evaporated in the cracks, and they are very common in the desert areas where the rainfall is less. And another type is the thermal expansion. Rock has a low thermal conductivity. That means I can still hold the rock in the hot sun. So its conduction potential is very, very kind of less. So they tend to make good insulator. When the rock is heated on the surface, that heat does not travel inward very rapidly. The heat will be concentrated only on the top. The heated exterior of the rock will expand more rapidly than the cool interior, causing the exterior to fracture, which we call it as falling. So what it is trying to say is, sun will be hitting only the top outer part of the rock because it is a bad conductor. The interior part of the rock is still not heated, which creates kind of a thermal gradient. Expansion will be more outside, while the inner part of the rock is kind of intact, which gives what we call it as falling. So thermal expansion gives rise to breaking of the rock, which are mostly found in the desert areas. So desert areas, there is plenty of such kind of example of thermal expansion. So such kind of thermal expansion was studied through the laboratory experiments also, and a lot of data and their understanding we have come to know from the actual laboratory data, and it shows that constant expansion and contraction in due course of time will start creating lot of tension, especially between the outer and inner layer of the rock, which gives rise to once again kind of shattering and sheeting, which are mostly very, very common in the areas where water is less and sun is the main agent of breaking. So we have seen those 4 types of physical weathering. The role of physical weathering is important in the overall weathering of the rock. It reduces rock material to smaller fragments that are easier to transport naturally. Weathering is going to break the rocks. So once it is broken into smaller pieces, any agent of erosion can lift it and it can transport it and deposit elsewhere. It also increases the exposed surface area of the rock. So the more is the surface area available, more space for atmosphere as well as water to contact with that will become the chemical weathering, which is coming up in the next point to be more speedy. So that is physical weathering. What is one thing that we saw about physical weathering is, the result of physical weathering gives rise to any topography which is very sharp, very angular, because it's all about breaking, whether it is in a desert or whether it is in the polar areas or on the top of mountain. Wherever the physical weathering is happening, it gives rise to all shattering and breaking and layering. So there is no softening or rounding, and therefore physical weathering gives rise to breaking and shattering, and therefore very, very angular and sharp landscape. Exactly opposite to that is the chemical weathering. So now let us see chemical weathering. First, what it does is, chemical weathering increases bulk, creating stress within the rocks. It lowers the density minerals. It decreases particle size, resulting in increased surface area. It creates more mobile material and it creates more stable mineral. Or in other words, very in short, what is happening in chemical weathering is, there is a rock here. The rock is composed of minerals, 2 or 3 or more or 4, but minimum 2 minerals are there in the rock. When it comes into contact with water or the sunlight, it's going to interact with the minerals which are present in the rock. Those mineral will transform itself into some other form. And in the whole process, we already saw that the chemical change has occurred in the mineral, that means chemical weathering has occurred. This will go on and on and on till a day comes that the mineral which are forming the rock has come into complete equilibrium with the minerals which are found in the water. So that is what it says, creates more stable minerals. So the definition of chemical weathering, it is the transformation or decomposition of one mineral into another. Or in other words, we can also say mineral breakdown. For example, carbonate dissolves, or the primary minerals go to secondary mineral, mostly clays. So first I will tell you what is the meaning of primary mineral and what is the meaning of secondary mineral. Primary mineral means the minerals which were present when this rock was formed. So if we talk about granite, we are talking about quartz and feldspar, or for basalt. So for any kind of rock, there are some primary mineral composition. That's what we call it as the primary mineral. The moment it is exposed into the atmosphere with the water, water already will contain some chemical into that. Those chemicals will be interacting with the minerals which are present in the rocks, and it will go on changing from one to the other, from one to the other, and till when? Till a day comes that it forms into a clay. That means it comes into a total equilibrium with whatever is the environment which is present. So that final dead end material is what we call it as a secondary mineral, one of the clay. So when we say chemical weathering, it is the path of all the primary minerals to form and change into the final secondary mineral. So mineral breakdown, the process that breaks down rock through chemical change. So how is it different from the physical weathering? In case of physical weathering, breaking down into smaller pieces without any change in the chemical and mineral composition. Whereas in case of this, it is breaking down, may not necessarily into a smaller pieces, but into another mineral. In due course of time, it is going to form into clay. So all the red soil that we see all over the ghats of Maharashtra, Western Ghat, they are the product of chemical weathering. The agents of chemical weathering, water is the most important agent of chemical weathering. You know why? Because water is the universal solvent. Water is going to dissolve in it the chemicals, and depending on which environment it is, it will be carrying different minerals or chemicals, and that water has to go into the cracks, or it has to infiltrate and percolate through the rocks. So without water, chemical weathering does not happen. So it's the most important agent. Oxygen, and in case of oxygen, we see the iron getting rusted, it becomes into red color. So rusting of iron, that is nothing but oxygen which is there in the atmosphere is interacting with the iron or Fe which is present in the rock, because iron is one of the minerals. Carbon dioxide, this is an omnipresent, because Carbon dioxide is there in the atmosphere. So, when the rainwater is coming through it, it will absorb carbon dioxide and that will interact with the rock which are there on the crust. Living organism, we will see it is one of the most important agents in the acid rain. Chemical weathering occurs more quickly at the corner and edge of the rock outcrop and boulder. These areas are more exposed to chemicals. This process rounds the rock and is called spheroidal weathering. Boulders surrounded in this way are called as spheroidal boulders. What the picture shows, the sharp edge of the brick becomes rounded by chemical weathering, because chemical weathering works more on the edges, rough edges. So, in due course of time, it turns into coarse stones or rounded stones, which are very common wherever we see. So, a rounded rock is naturally not possible unless it is done by the chemical weathering. Rocks which are piled on top of, this will be studying in a chapter called Inselbergs. These are all in situ. It appears as if one rock is placed over the other. It's not like that. These are all the product of chemical weathering. So, water is the main operator. It dissolves ions, an organic compound, and interact it with the minerals, transforming it into another. So, now let us see what are the different types of chemical weathering. These are the four main: solution, which also is called as dissolution, oxidation, hydrolysis, and the hydration. One word of caution: when we say different type of physical weathering or chemical weathering, you shouldn't believe that they are operating in isolation. They are all occurring at one time, but depending on what is the environment and the climatic condition, one of them predominates, that is it. So, now let us see one by one. What is dissolution? That is, soluble compounds such as limestone are dissolved, like sugar or salt, they simply dissolve in the water. Likewise, there are such soluble compounds, they just go into solution, that is one type. The second one is oxidation, which I briefly mentioned earlier. Minerals, ions combine with oxygen to form an oxide. So, मराठीमध्ये त्यांना गंजना म्हणतात, गंजलेला, that means rusted. If I keep an iron substance, a hairpin or a screw, or even the car ka parts you see, you leave it in the water and atmosphere for say 1 month, 2 months, 3 months, it starts turning into reddish color, and if you keep it for long enough, one day you will be able to break it also. So, what is happening is oxidation. The iron which is there in that is interacting with oxygen which is there in the atmosphere. So, it forms rust. Hydrolysis, that is water which contains chemical actually and physically interacting with minerals which are there in the rock. So, now let us see what is solution, dissolution and carbonation. It is a process by which rock or mineral is dissolved in water. It is very strongly influenced by pH and temperature. pH means the concentration of hydrogen ion, or we call it as acidity. It is a scale with 7 at the neutral. Anything which is lesser than 7 is acidic, which is more than 7 is alkaline. So, when the acidity becomes more, that means the value of pH is less, and when the temperature is high, chemical weathering becomes more. When water becomes saturated, chemicals may precipitate out, forming evaporite deposit. An example: I take salt, stir it in a glass of water, 1 spoon, 2 spoon, 3 spoon, 4 spoon, and then a time will come that it will no longer dissolve because it is become saturated. So, such kind of saturation happens in the chemical weathering environment. But sometimes, if you evaporate the water, these salts will get precipitated or deposited once again as the evaporite deposit. So, calcium carbonate like calcite, limestone, sodium chloride like salt, and calcium sulfate like gypsum, they are vulnerable to this kind of solution weathering. The picture is very common. So, H2O plus CO2 plus CaCO3 will lead to Ca2 plus 2aCO3 negative sign. And very simple example is, you will find it wherever the limestone is present. Statue without nose, getting pock marks. Then oxidation. Oxygen, the second most common element in the air, reacts with iron in the mineral to form an iron oxide, that is hematite. So, it is another form of rust. As many minerals contain iron, it is not unusual to see red colored rocks, and red colored soil, you see it everywhere. Here, at least in Western Ghats and Maharashtra, the breakdown of rock by oxygen and water, often giving iron rich rocks a rusty colored weathered surface. So, oxidation, such kind of pictures we will see everywhere. Then hydration. There is difference between hydrolysis and hydration. Students should not get confused. Hydration is attachment of water molecules to crystalline structure of a rock, causing expansion and weakness. I'll say there are some minerals like feldspar. They have a tendency to just take the water. So, there is no chemical alteration. It will just absorb. It will just drink up water and it will start expanding. During this process, there is change in its composition. So, hydration is different, hydrolysis is different. In case of hydration, it is just attachment of water molecules to crystalline structure of a rock, causing expansion and weakness. Now, hydrolysis. It is the breakdown of rock by acidic water to produce clay and soluble salt. So, water will contain some chemical that is going to interact with minerals which are there in the rock. In due course of time, it will come to a dead end in the form of a clay or soluble salt. This is where acidic water reacts with rock forming minerals such as feldspar. This is a common process in the weathering of granite. Feldspar are an important silicate mineral group in granite and granite type stones. It contains potassium, sodium and calcium. Hydrolysis causes the feldspar to break down into a secondary mineral, that is kaolin or kaolinite, china clay. While the feldspar in granite decomposes, the quartz and mica remain relatively unaffected, but the structure weaken. That means quartz is a very stable mineral, so they do not go into solution very quickly. And hydration is the chemical addition of water molecules to a mineral. This process frequently produced a new mineral compound. In addition, the size of the mineral structure is increased, causing stress and developing zones of weakness. This can increase the overall permeability of the stone and lead to spalling, pitting and flaking, means all kind of breaking. Color also change and it can take place as well. So, taking water expansion and becoming weak. So, some geologists and geomorphologists even believe that hydration is not a part of chemical weathering, it should be physical weathering, but it is both physical and chemical weathering. It involves weakening as well as change in one feldspar to the other. When the rocks were formed, lava comes out and lava cools, that is how the rocks are formed. Before the rocks are formed, first the minerals are formed and there is a chain in which different minerals are formed. The first group is called as olivine. Olivine mix with the melt or lava and forms into pyroxene. Pyroxene mixes with the melt and forms into amphibole. Amphibole into biotite. And finally, the last is quartz. This will be explained in detail in the specialization paper, that is tropical geomorphology. Once again, there is another path, continuous path, that is one feldspar which is very calcium rich has become into sodium rich. In short, I will tell you like this: different minerals have been formed at different temperature. The one which was formed at the earliest and the temperature of the lava is very high, they are the ones which are least susceptible to weathering. And those ones which are formed at a temperature which are very close to today's temperature, they are very, very resistant, and two extremes are olivine and the quartz, in between pyroxene amphibole. And another reaction, that is calcium, the feldspars which are formed in the high temperature will be very rich in calcium. They become richer and richer in sodium, and they join together finally to form quartz. This is called as Bowen's reaction series or resistance to weathering. Some pictures, and you will find plenty of pictures of these minerals: olivine, plagioclase, feldspar. Biological weathering. Actually, biological weathering is the combination of physical and chemical weathering. That means the roots of the tree will break the rocks. This we see it everywhere. But what it is doing is breaking. So it can be physical, but who is breaking? By the tree. So it is biological breaking. Then burrowing animals, the root is breaking into rocks, or these are, lichens, sheware, lichens, moss. They are attached on the rock. They allow water to absorb more and more and form into chemical weathering. Snakes or earthworms, burrowing animal, rabbit, they are also loosening the rock and soil. So these are all biological weathering. So we have come to the last part. I will briefly tell you. We have already seen there are two types of weathering. One is physical weathering or mechanical weathering. The other one is chemical weathering. And climate and temperature, they are the determining factor. Where will you find physical weathering or mechanical weathering? Where water is less and where the temperature. For example, you will find it in polar areas, on the top of the mountain. You will find it in the desert areas. Where will you find mechanical weathering more? In the humid tropical areas where the rainfall is more, in short. Why? Because we require very high rainfall, high temperature, together vegetation. What the vegetation does is, the leaves and twigs in the forested area, the organisms die. They accumulate on the surface and they become rotten or decomposed and form humus. So when the water is falling through it, water will take these organic acids, and organic acids are capable of breaking the very resistant minerals like iron which is there in the rock. So wherever the joints are more, rate of weathering will be more, because it is very straightforward, water is going into it. So the more water it is going, and also what kind of fracture. If fracture is vertical, more water will go. Greater the surface area, more place for the chemical weathering to take place. So the first point to remember, weathering is the breakdown and alteration of rocks at Earth's surface through physical and chemical reaction with the atmosphere and the hydrosphere. Physical weathering or mechanical weathering is the mechanical fragmentation of rocks from stress acting on them. Ice wedging may be the most important type, or frost wedging with that salt weathering or even exfoliation. Chemical weathering involves chemical reaction with minerals that progressively decompose the solid rock. The measured types of chemical weathering are dissolution, acid hydrolysis and the oxidation. Joints and fractures promote weathering because they allow water to go into it, an atmosphere to attack. They also greatly increase the surface area on which chemical reactions can occur. The major product of weathering are spheroidal rock form, blanket of regolith and dissolved ions. Soil is the upper part of the regolith, a mixture of clay minerals, weathered rock particles and the organic matter. Climate and a rock type greatly influence the type and rate of weathering. A weathering profile. Below we will have the rock which is partially decomposed. As we go on top, they become more and more and more weathered, with the top becomes completely weathered. So, this whole section is what we call it as the weathering profile, and the contact between the weathered part and the below, which is unweathered, is called as the weathering front. Study of weathering profile gives us a very good information about the processes which are operating in the area. The actual photograph of weathering is. One more thing before I end. The whole weathering profile is called as saprolite. So, a word called saprolite, S-A-P-R-O-L-I-T-E, and regolith, R-E-G-O-L-I-T-H. These are the two words which are associated with a weathering profile. So, with this, I have put the weathering into a nutshell, and I believe you must have got a part of it. Thank you, students. So, now let us summarize what we did in this lecture. We started with definition of weathering. Weathering is the disintegration and decomposition of the rock in situ. So, these three words have said everything about it. Disintegration, breaking; decomposition is change in the mineral in situ without changing. The agents, just atmosphere and the water which are present into it. We have spoken about the different types of mechanical weathering, the different type of chemical weathering and the biological weathering, and ultimately we also have seen what is a weathering profile. So, after weathering, now we will be doing a very important and basic which is very connected to weathering, that is mass movement or mass wasting. Gravity induced movement of material from the higher ground to the lower ground is called as mass movement, and mass movement can only be possible when the rocks have been softened and broken by weathering. So, the next one is mass movement.